Hello, you absolute legends. We can have chemical reactions that produce gases as a product. So, for example, we can have solids decompose to produce solids and gases. Some example of that right here is sodium chloride, an ionic salt, ionic compound we call table salt, can be decomposed in extreme conditions to sodium the solid and Cl2 the gas. We're going to approach this problem with the idea that if we start with 10 grams of sodium chloride, what is the pressure of gas that will be produced in here? And I'll say that we have the temperature. Let's say the temperature is 273 Kelvin, and then the volume is 10 liters. And we're solving for the pressure that could be that the Cl2 chlorine gas would produce. This is a long problem. I hope you got your coffee ready. Our first step is to balance this chemical reaction here. Nailed it first time. 2, 2. I'll put the 1 in there. If you needed to do accordions and your ledger, hey, no problem there. So this problem is solved in two steps. The first step is an old, and the second step is the new. The old is you have grams of a product and you solve for grams of the reactant. That's the old. That's the first step. The second step is taking that grams, mixing it with the pressure stuff, and that is something new. This written here in blue is our basic outline for solving this problem. Grams of a reactant to grams of a product, and because that product happens to be a gas, we can fold that into gas stuff. Let's get started. I have 10 grams of NaCl. (23 plus 35.5). 58.5 grams per mole. Grams cancel. We use coefficients from the balanced chemical reaction. 2 NaCl. And we're trying to solve for chlorine, so 1 Cl2. Now we solve, chlorine gas is Cl2, so 3571. 71 grams per mole. Now that would solve us for the grams of Cl2 that could be produced. I'm getting 6.07 grams. Of Cl2 that could be produced. So we did that whole first step just to now get into gas types of problems here, or gas types of equations. Just like the previous gas problems we did in this chapter, when we have gases and we're working with gases, we know that the ideal gas constant is fair game. That may be used, and probably will be used, to solve for something about the gas here, whether it's temperature, volume, pressure, or moles of the gas. Now, let's just write down the ideal gas constant, 0.0821 liters times ATM moles Kelvin. Okay. I need my pressure is what I'm looking for. So when I start my scaffold, I'm going to make sure that I have pressure in the numerator using my ideal gas constant. I have pressure in the numerator, so now I just have to cancel out everything else here. I need liters to cancel out. Great. I have a number for liters, 10 liters. Cross that off my shopping list. I need the temperature to cancel. Great, 273 Kelvin. That cancels out. Units cancel. Top cancels out bottom. Now, I know, man, I need to solve for pressure, but I have moles to cancel out. I don't have anything in my shopping list with moles. Let me step back for a second. I've already used this number. I used this number in the beginning of my first scaffold. Wait a minute, this number I haven't used yet. I only calculated it to get to the second step. Let's be clear here. This is the connection I'm trying to make in my head right now. I have a unit, I have a number with a unit of grams. I need to cancel out moles. I want to flip through the phone book of chemistry in my head and science and say, is there a unit that combines both? Is there a number or a constant in a formula that also has grams and moles together? And that is the molecular weight of any chemical always has the units grams divided by moles. So we're talking about Cl2. So I can use that right there. 71 grams per mole, the molecular weight of chlorine gas. Top cancels out bottom. And now I can plug in the 6.07 grams that we solved a little earlier. Cross that out because we used it. This was a long problem. It still fits a lot of the criteria that we've talked before. We've used everything in our shopping list, okay? We used the number we calculated in the first step. I mean, if we didn't do it, if we didn't need that number at some point, we wouldn't have calculated it. We've used everything in our shopping list. The unit we're looking for is in the numerator. Now let's pick up our calculator and solve for the pressure of chlorine gas that would be produced when table salt, when 10 grams of table salt decomposes. I hope this helps. Thank you.